So we have created shots and we can now shoot them. But we have a problem. Our shots are simply accumulating in the scene, flying off towards infinity on the z-axis. Even though each shot only requires a tiny amount of our resource budget, we will quickly have a lot of them, each being processed and moved and tested in our scene. We need to find a way to remove these shots from the scene when they leave the game area. There are a number of different ways that we can approach this issue. In this assignment, we are going to create a box around our game, and we will destroy these shots as they leave the box. As an added bonus, this boundary box will also deal with our hazards and destroy them when they leave the game area as well. To create a box around our game area, create a new cube by using the Create menu and selecting Cube. Now, a cube has a mesh held by the mesh filter and a mesh renderer that we don't strictly need for our purposes. We only need a box collider component. However, being able to see the cube rendered in the game view will be helpful to us when placing the box around our game area. So, we'll use a cube with its mesh renderer, and box collider for our bounding box. Rename the cube Boundary, and reset its transform to make sure it is at origin. If we turn the mesh renderer off, we will see the box collider in the scene. We don't want a physical collision with this box. We want this box to trigger a new action when our objects leave this box. We want this box to be a trigger collider. So on the box collider component, select isTrigger. Now, in our game view, we can't see our boundary. The gizmo indicating the box collider is only visible in the scene view. The trigger collider by itself is invisible to our game camera. This makes sense, though. We don't want to see our triggers in the game. This is why using a cube makes sense. Let's turn the mesh renderer back on. We want to place this box evenly around the game area. The center of the game area is defined by the position of the camera as it looks down on the game. The camera's transform on the XZ plane is 0, 5. So let's keep the boundary's transform position X at 0, and let's set the boundary's transform position Z to 5. Next, using the transform scale, let's change the scale of the cube until it surrounds our scene. We are less concerned by the sides for this particular game, as nothing will leave the game area by the sides of our game. Our background is 15 units wide, so let's match that with our cube and use a value of 15 in the transform scale X. The top and bottom are more critical. We want to get the boundary as close to the edge of the game area as possible, as all of our shots and hazards will leave the game area by the top or bottom edge. This looks like about 20. So let's use a value of 20 for the transform scale Z. We actually know that 20 is the correct value, because 20 is twice the size of our orthographic camera. The number of units from the top of the screen to the bottom is always twice the value of our camera's orthographic size. Now that we have placed the boundary, we can turn off the mesh renderer. When we look in the scene view, we can now see our collider in green surrounding our game area. We now need to have our boundary do something. To do this, the boundary needs a script attached. So with boundary selected, click on Add Component. Then select New Script. Rename the script Destroy by Boundary. Accept these changes to add this script to Boundary. Select Assets to see our new script in the root level of our project. And let's file it in the Scripts folder. Open the Scripts folder and select Destroy by Boundary, and open it for editing. Our boundary game object's behavior will be driven by the box collider, and that box collider is a trigger. To find out how to script to a trigger collider, we can search trigger in the documentation. This will give us a list of all of the uses of trigger in Unity's API. We want to destroy the shots as they leave the box collider's trigger volume. So let's look at on-trigger exit. If we look at the description, it tells us that on-trigger exit is called when the other collider has stopped touching the trigger. Conveniently, the sample code does exactly what we want. When the other collider leaves the boundary's trigger volume, we want to destroy the other collider's game object. Copy this code and paste it into our script. Save this script and return to Unity. When we select Boundary, we don't see any properties on the component. This is because there are no options we can set on this component. This component simply does its job if it's active, destroying any object that leaves the trigger's volume. Now that our boundary is set up and in position, we can remove the mesh renderer and the mesh filter components. Let's save the scene and test. And, as the shots leave the game area, they are destroyed. With our ship set up and its weapon systems ready to go, in the next assignment we will create hazards to challenge our player.